variation, which means sometimes the problems are kind of long. I should have printed these notes out for you, but I was not nice today.
Well, you have time right now. I mean, that would balance it out because if you printed them out, it
That's
would
all right.
be better because we're still going to spend the same amount of time doing notes.
It's all right. It's all right. We're good. We'll just shorten up our problems. A power function is any function that can be written where x is to a power. That's really the short of this. It says any function that can be written in this model where k and a are non-zero constants. Basically meaning like there's numbers there. K could be 1, right? Like x squared is a power function. We call the constant a is the power, which we all know that, like x squared, the 2 is the power. But the number in front, most of the time we don't think about this except for when we talk about variation problems. We call that the constant of variation, or sometimes we call that the constant of proportion. I don't really call it the constant of proportion. The book calls it that. And so when we do some problems later where we talk about something varying directly or varying inversely, I think you'll have some vague memories of this from Algebra 2. But we don't usually think of it in this format. So, okay. Part of your homework today is just determining whether something is a power function or not, and if so, what is the power and what is the constant. And sometimes I give you little tricks on this one, so we're going to practice that. All right. Can I go? Not go? Maybe go. Mason, why are you sitting over there? You have a forever new seat, though. Over here. Would you like to borrow a pen?
Hey, guess what I did today?
I don't care. You have to write first. You always talk to me, and then you're not ready to do notes. So you write, and then you can talk to me. This is what your homework says today. Determine if the function is a power function. And they tell you in the directions that c, g, k, and pi are all constants. And then they want you to state the power and state the constant of variation. People get very confused by this. How was your letter writing today in engineering class?
That's what I was going to talk about. I'm a little
You have to
rebel.
write and talk at the same time.
I'm a little rebel, like I am, and I just skipped engineering class today and slept. Yeah, I heard it.
So is the absence policy the same there as here? Like if you miss so many, you're going to be in trouble, right?
Yeah.
So I don't want to do that a lot.
Well, yeah, one more.
Did you talk to Mr. Gardner and Mr. Wildminster about dropping that class?
No.
You should do that.
You're gonna drop it?
Like it's
Yeah.
expensive. Are you in that class?
No.
It's terrible. You gotta wake up earlier. You gotta miss all this stuff, all this fun stuff.
Coming in early.
You're talking about how much you like class.
The thing I like about the class is I made a friend in the class, so we talked the whole class, like Candy Crush.
Yeah.
All right, so number one I feel like is a power function that we're used to seeing. Negative 1/2 x to the 5th. We have a constant in front. We have a letter to a power. Very much this is a power function. So is it a power function? Yes. State the power and the constant of variation. So what's the power in this one? Power is the exponent on the variable, so the power is 5. And the constant is negative 1/2.
So it has to have a constant and a power.
The constant could be 1, right? Like if I asked you if x to the 5th was a power function by itself, we'd still say yes. The constant would just be 1. Do you agree with that?
Yeah.
But it has to have power to be a power function.
You say you agree with that. Have you ever had anybody just like that?
Yes. Which is why I asked, but lots of us don't say that. I like to say yes, no, maybe. I say that also too, but sometimes no one ever says anything. I'm looking for like nods. Yes, I understand. But no, I have people that disagree with me a lot. Sean Lowe disagrees with me a lot. Logue. And some people just always want to add more to it or ask me like, well, what about if we did this? But so yes, that's why I ask. Sometimes when I record notes, I ask that same question. Do you agree with me? Then I just like to, but I like to just ask that, even though you can't tell me. Yes or no?
No, I don't.
So look at number 2. Number 2 is the one that people get confused by because there's lots of letters in this. It says E of m equals mc squared. Is that a power function? And if so, what is the power? What is the constant? This is where the notation should help you, and the fact that they tell us that c, g, k, and pi are constants. So if this was a power function, which maybe we haven't decided yet, but what is the constant in this function? C. Lots of people want to tell me that it's the power because it has a 2 on it, right? But they tell me up here that c is a constant. So that means this is my variable. They should also have told you it's a variable. Think about normally we do like f of x, right? So that's your variable, m is your variable. It's like, why is it no? Could I write it as c squared m? Isn't that the same thing?
Yeah, you can't power your,
Why not?
you're breaking a math law. You're breaking
This is, what does this stand for? Energy equals mass. And what's the constant, do you know? I feel like it's like acceleration, but I don't know. Should ask Miss. It's just a formula, and it can be, the constant can be squared. It's kind of weird. Normally not squared, but it is still a power function. So the answer there is yes. And what is your constant? Your constant is not just c. Your constant is c squared, like the whole thing. And what's the power on our variable? 1. 1 is still a number. Because the m is the variable, so it's the power of 1. The c squared is not our variable, right? The c squared is our constant. That's what's tricky about that, which is why it's important to notice on your homework today, c, g, k, and pi are constants. Not me, the book. What about this one? Is this a power function? You have to have x to a power. You can't have x in the exponent. That's not a power function. No.
Have you ever heard the cat rap?
No. Normally we call these functions monomial functions, and so if you look at this, you're going to see that this is very similar to what we just wrote out for power functions, except for one thing. So I'm going to let you write this, and then we'll talk about what's the difference between a monomial function and a power function. It was that right? No, my alarm goes off at 5:13 every morning.
5:13.
I don't know, because I just like to set it for weird times. I want to get up by like 5:15, 5:20, so I set it for like 5:15, 5:09.
Last week I set my alarm for like 3:30 because I had like nothing done. And so I set it and then it didn't even go off. So I ended up being up at 6. And I didn't set my alarm last night and it went off at 4:30 this morning. And that was like a week ago. And I don't know why. And so I woke up at 4:30 this morning. My alarm was just going off.
I woke up first at like 7:06. And then I got a shower, I got dressed.
And then you just went back to bed?
Yeah.
That's weird.
No,
If I got up and got a shower, like I could go back to bed. Like,
I can't.
it's like 2-hour delays days. It's like I'm always up if they call a 2-hour delay in the morning, and like I can't go back to bed.
Well, that's when my mom and dad are nice and wake me up 2 hours late.
I've just had 3
I don't know, dude, it is the best game I've ever downloaded.
Okay.
Candy Crush.
Any function that can be written as a form f of x equals k, where k is a constant, or f of x equals k times x to the n. Notice k is still a constant, But n is a positive integer, and if you go back and look at the definition that you wrote for a power function, the power could be anything. Like the power could be negative and it's still a power function, but to be a monomial function, you can only have positive exponents. And so that's the difference between a power function and a monomial function, so just kind of be aware of that. But you also have some questions on your homework today that just say, is it a monomial function? And if so, what's the degree of the leading coefficient? Which I feel like we're pretty good at, right? Polynomials, we did that the other day, didn't we? A monomial is just a polynomial with no addition. Mono meaning one, poly meaning many. So let's do a couple of those before we get to the good stuff. Determine if the function is a monomial. If so, state the degree and the leading coefficient. No. Well, trying to think, like if it was like x plus 7 squared, but no, I think we would say that's not a power function. A power function is just constant, a variable of power. Right. Talk about this later. Aaron. Should I leave the movie over here by Mason?
Oh, I don't know.
No, I don't want to do that. That's not smart. It'll be a punishment for Mason.
Don't call me a monkey. Do I look like a monkey at all?
You act like one on the tennis court.
Is this a monomial?
Yeah.
What's the degree?
7.
What's the leading coefficient? Oh my gosh, we're so good at this.
Wait, is it degree or power?
Well, now we're talking about monomials, so they want us to talk about the degree, which is the same as a power, right? Like it's just, that's why they put these both in the same section, because a monomial function could also be a power function, but not all power functions are monomial functions. Like that whole thing, like a square is a rectangle, but not all rectangles are squares. See that? Leading coefficient is -6. And what if I gave you this? Can't have an x and exponent. That's some good homework time, right?
So,
We're done.
No.
I was gonna say.
That's the easy part of homework.
Okay, but, so pretty well, as long as it doesn't have an X,
It's a power function, but if it had a negative exponent, right? Think about what we did with 2, 1, day 1. Like you can't have a negative exponent, and that's not a monomial. You can't have like square root of x. That's not a monomial. It could be a power function, but it's not a monomial. So to be a monomial, the exponent has to be an integer. So that means no fractions, no decimals, no crazy stuff. Yes. Okay, so monomials have a lot more restrictions on them than power functions do.
power functions pretty much everything.
As long as you have, a variable to power, even a power of 1 is a power function. So the other stuff is, now that we can talk about power functions, now we can talk about these variation stuff. So I'm going to give you all the variations and kind of what to expect when you see a problem, and then we're going to practice a couple of them. And the worst part is writing the problem, which is why I probably should have printed your notes out. But we'll just shorten those up for us. Okay? Lots of good science problems. But when we talk about variation problems, these are power functions. And so I wrote up here, K is like that constant of proportionality or the constant of variation that we say. And if something varies directly, that always means multiplication. So here's your equation, y equals k times x. And if you see in your homework today, if you see the word that something varies directly as something else, or if you see the words directly proportional, that means the constant is just multiplied by whatever value is that you're talking about. So directly related means that you just multiply the constant times x. As opposed to if you had inverse variation, and to me it makes sense, inverse, you like flip it over. Inverse variation would be when you have the equation and you have k divided by whatever your variable is. That would still be a power function. just have a power of -1 on it. And again, it's all about recognizing the words in the problem. And so for inverse variation, you're looking for the word that it varies inversely or that it's inversely proportional. And if you see that, you have to know that you're writing it as division. Going back to this one, sometimes they don't even use the words directly. So let's go up here and let's add that also sometimes it just says proportional. So I don't know how you want to write that. Also, we could just say that y is proportional. To x. So if it doesn't say directly in front of it, it's kind of implied that it's directly. And then the harder one is if you have joint variation. Joint variation is where you have two different variables related to z. It's still multiplication. But again, it's really easy to know if it says varies jointly or is jointly proportional. Remember doing this last year?
My hope is like whenever they put like different letters, like.
Right, and that's what your homework is. We're going to practice with this because they're not always going to use k, x, and y. They're going to actually give you more story problem kind of stuff, which is where you have to figure out what to put where, which is what we're going to practice next. And that's it. Like just practicing these problems here, and then you get to work on your homework.
It's almost done.
Most of your homework today is direct variation, but it's again written not just directly, like it's lots of other stuff around it. So we have to figure out what to put in there. So I'm going to give you the directions, and then I'm going to give you a problem, and it's up to you if you want to write the directions down. All right? Everybody okay with that? Any questions? People okay with that? Look how fast you can write when you're not talking so much.
My brain's never been wired.
So this is the directions on the majority of your homework today. It says write the statement as a power function equation. Use k for the constant of variation if 1 is not given. So sometimes in the problem it's going to say where pi is a constant or where c is a constant. So if they tell you what constant to use that constant. But if they don't tell you, then you're supposed to use k. So number 6 is a geometry formula. And it says the area A of an equilateral triangle varies directly as the square of the length s of its sides. So I'll try that down and then we'll kind of figure it out. That's your prerogative. You write what you want to write. Mason writes nothing. So.
I absorb.
Yeah. But you know,
Dano writes nothing.
I mean, like all
Oh,
my
this is
homework
for class.
electronic.
I don't think it's a good day to just absorb.
I write it all.
Like I feel like there's a happy medium. Like sometimes you can shorten things up. But that, I don't know. I feel like the words are kind of important on this one.
But see, like instead of
We should
writing
have a tornado
triangle,
drill stage.
I drew it.
That was not.
Oh, those are the best though.
Well, I read up to those days.
It's best because you also have to drill.
Like
That's really
yesterday,
nice.
I didn't know that fire drill was real.
Miss Dad made us so weird,
Yeah,
guys.
I-
They had to do their notes too, Allison.
I was gonna say, I think it must have been my fault. Because I said something about, like, you mentioned something about that, and then she was like, grab your notes. I'm like, oh no. We were just doing test corrections, and so I was like, take your test with you. And Noah said, this is embarrassing. So,
People are out there laughing at us while we're sitting here releasing and doing our
and so we just sit in the grass and talked about it. I brought my chalk, but I didn't use it, so.
In a real like fire tornado drill though, people wouldn't be like walking, just barely walking along.
Well, you know, we try to practice so that in a real one you would be ready. Right, you might be running to your designated area if it was really, but like when I taught at North Montgomery, there was a real fire like in the dryer, but we didn't know it was a real fire. Like they just called a fire drill and we just went outside, but then after like 30 minutes, we're like, I think there's a real fire. Yeah, we ended up sitting out there forever, and that was like my first year of teaching before I knew I had to make kids take stuff with them. So we just sat out in the grass for a few hours until they dealt with the fire, and then we went back to school.
We were,
High school burned down.
we were at a hotel and the fire alarm went off, and I was sleeping in my underwear, so I had to wrap up in a sheet, stand outside and wrap in a sheet on the porch.
I went to ISU, and my freshman year, I lived on the 10th, no, I lived on the 9th floor, and there was a real fire on the 10th floor in the middle of the night, and I totally slept through it. I could have died. Like, no one came around to check to make sure everybody was out of the rooms. But my roommate never shut her alarm off, and, like, so I woke up to the fire alarm going off, and I was like, Heather, turn off your alarm! And then I just went back to sleep, but Heather wasn't even in my room, because who knows what Heather was doing. Not in my room. So she wasn't in there, and the next day people were like, man, it was so cold outside, I can't believe we had to go outside and there was a fire. And I was like, what, there was a fire? One floor above me, there was a fire in a trash can, and I just slept through the whole thing.
Yesterday, during the fire drill, I was sitting on the pod doing some biscuits when it went off.
Eric, sometimes there's just too much information that you can share.
It scared me. I was like, oh my, this can't really happen.
So, they're not going to just use X and Y. You did that last year in Algebra 2. Like, it's pretty easy when they give you that. You have to look for the letters and look for the notation here. It varies directly, so that means your format is that whole Y equals K times X. But you just have to fill in Y varies directly as X. So what would the Y be in this case? Yeah, the area varies directly as the length, as the square of the length S of its sides. How would I write the square of the length S of its sides? S squared, and did they tell me what constant to use? No, so that means I would just use K. There's actually a formula to find the area of an equilateral triangle.
Is that all we do?
That's it. There's nothing to solve here.
Wow,
Will there ever be anything that you feel?
Yes, maybe. There might be some on your homework that they give you some points to then plug in, and we're going to do one of those in a minute.
Okay.
But if they just say write the equation, that's it. You write the equation and you're done. Don't forget there should be a constant in there. So don't just write a equals s squared, right? There's some constant there that you have to multiply by. Okay, and I think it's like the square root of 3. That's my remembering from geometry class, that you can take the square root of 3 times the side squared, and that gives you the area. But you don't have to know that. Okay? Let's do another one, and maybe we can shorten up the problem a little bit. Like, you could definitely leave out free falling. The speed p of an object, you could probably just leave out the whole that has been dropped from rest, varies as the square root of the distance traveled d. Yeah, I think you need to write the rest. That's all kind of important. Otherwise you can't write the equation. But all the free falling, drop from rest, that's just some jazz in there. And I got one more after this. I think you should skip engineering everything. Don't really skip.
I
I'm
would
just
love
kidding.
that.
Freaking don't. They're on its day.
I gotta wake up.
Notice they give you what variables to use. The speed p of an object varies. Again, notice it doesn't say directly in here. So if it doesn't say directly, inversely, or joint, like it's always implied that it's directly, as the square root of the distance traveled d, and they actually give us a constant of variation of k equals the square root of 2g. I like to start with my y equals kx and then just plug in what I'm supposed to plug in here. So what's y in this one? P. Do I know what my constant is in this one? The square root of 2g. And what is my varies as the square root of the distance traveled d? Yeah, the square root of d, and really, I think it would look much better if we put it all under a square root, since it's all square rooted. Like, if you wrote that as your answer, it would be right. But you could take the speed is equal to the square root of 2 times g, which I'm guessing has to do with gravity, and the square root of the distance.
Okay, how did you know?
Because if it just says varies,
Oh.
right? So like varies directly is directly proportional, or if it ever just says varies or proportional, it's always directly.
Okay.
And I think almost all your homework is directly, so that's a good little hint too. All right. So then we can also actually solve this. Colin said, are we ever going to have to do any more with this? And you are. And this one's kind of long, so let's bear with me, and I'll see if we can shorten this up any.
That's a.
So definitely you need to write the first sentence. The power P in watts produced by a windmill is proportional to the cube of the wind speed V in miles per hour. You can shorten however you want to shorten it, but and then this is giving you some information so you can actually solve the problem. It says if a wind of 10 miles per hour generates 15 watts of power. So I mean you could shorten that a little bit and you could just say 10 miles per hour generates. I'm just going to go an arrow. 15 watts. If you wanted to shorten that sentence up, if you feel like you'll know what that means, you're trying to figure out how much do winds of 20 miles per hour, 40 miles per hour, and 80 miles per hour. So you're trying to find the wattage that goes with each one of those. Or you can just write it off. It's the last one, so you can decide how much paper you got left, how much finger strength you have left for writing.
I work my fingers on everything.
Sometimes I have kids that come to my class that say I'm the only class that they have to pick up a pencil in. And I say, no wonder people hate my class.
I haven't been taking notes and they keep writing them, and
That's
I'm
not
getting
good.
kind of nervous about it.
Yeah. I don't know if that's a good thing.
What? Well, I mean, like in class. Whenever I do notes for each chapter, I just go to the back and copy down the different chapter summaries.
If they give you a problem, they ask you to solve it. Step 1 is you have to make the equation like what we did on the last 2 problems. So that should be your first sentence. Like you shouldn't need any of this extra stuff to write your equation. The power P produced by a windmill, so P is proportional to the cube of the wind speed V.
Yes.
So how could I write that equation?
P equals.
So P equals, the cube of the wind speed V, so that would be V cubed and times some constant. That would be your equation. If it just said write the equation, we're done with that. But they actually want us to solve it, which means they have to give us something to solve for K, and then we have to use that to find what's missing. So notice the next half of that sentence. If a wind of 10 miles per hour generates 15 watts of power, if they give me the wind speed and the power, can I plug that in to solve for K? Yeah. So I could say, using this equation, P equals KV cubed, a wind speed of 10, so that's the V, generates 15 watts of power. I can actually solve that for that constant of proportionality because it's going to be the same constant for that particular windmill. And 10 to the third is 1,000. So I could divide by 1,000. And I would get that K equals 3 over 200. Is that right? And if you want to write it as decimal, you can write it as decimal.
That's pretty good. Little math.
0.015, I think. I just divided by 5 on top and the bottom. Right. Which means we could actually write the actual equation plugging in K, whether you write it as 3 over 200, or if you love decimals and you want to write 0.015 V cubed, right? That is the equation that gives you the power for that particular windmill. which means now you can actually answer what it's asking you to do. So you got to write your equation, solve for k, then actually solve what it's asking you to do. And it asks you to find the power generated by 20, 40, and 80 miles per hour. So we just want to find the power when V is 20, when V is 40, and when V is 80, and you definitely can just use your calculator. Like the last part's just plugging it in. First part is the algebra part. So you're just going to take 0.015 times 20 cubed, 0.015 times 40 cubed, and 0.015 times 80 cubed. And I got 120 watts of power, 960 watts of power, 7680 watts of power. So that's the uses of power functions, is you can actually solve for k and then use that to find other things. We'll do more with that. We'll do a lot of half-life stuff this year. Remember that fun stuff? Like half-life or carbon-14 and chapter 3. But today, though. So here's your homework. This is 2-2 notes. We only have one day of 2-2.